All right, everyone, 1/7 of the way finished, and we've actually hit up the most popular question, which was an 18 of you wanted to see question 9 in the video. But there's still 7 of you out there that said yes to every single question, so we're gonna do it because hey, you asked for this. So let's go. The graph below. We're talking question 12 here, everyone. Let's do a different color so that people don't die of boredom. Yes, that's going to be the thing that prevents you from dying from boredom, Mr. Jennings, is if you change the color of your pen. The graph below represents the relationship between Raina's distance from home and time. During which section of the graph does Raina travel the fastest? Looks to me like P and R are pretty fast. Okay, how do I know they're fast? I look at the steepest slopes. The steepest slopes will show me these things. So let's see. P. Okay, so distance from home. This is 1 point. Let's zoom in. Okay, we'll zoom in. We'll be able to discuss this a little better. All right, here we go. All right, so 1.5 kilometers over 2 minutes. Wow, that was pretty quick. Okay, and then how about R? R goes between 4 and 2, also in 2 minutes. R will be faster than P. Why? Because she goes further in the same amount of time. So she's faster. R. All right. Why is W the slowest? Let's take a look. W has the flattest slope. Okay. For W, we go from 2 kilometers to 0 kilometers. That's the home stretch. And this acreage of time goes from 9 minutes all the way to 17 minutes. It takes her 8 minutes to do the last 2 kilometers. I hear my children are torturing each other downstairs. I may need to pause this video. So, R. R is the fastest here. I know how to get their attention. I'll pause their TV show. Okay. I will pause this video and sort out my children. One moment, everyone. They seem to be okay. All right, let's keep going. Okay, so, anyway. Let's see. So, the graph below represents the relationship between distance and time on Javier's walk. All right, so let's see what Javier's up to. Okay, it looks like he distance. How much greater is Javier's speed in section P than section Q? Okay, well here we need to figure out his speed. All right, his walk. When you say his walk, I think that he's like going on a stroll. But it turns out that this stroll only lasts 7 seconds here. This is when his stroll is finished. Okay, so let's label some points. This is where I would start labeling some points. This is the point 0, 2. Right here. Right here. Okay, that's the point 0, 2. This is the point 3 in the x and 14 in the y. 3, 14. Okay, and then this is the point 7, 18. That's point 7, 18. Now we can calculate the slopes for all of these. And let's change the color of the pen to be super exciting to a super exciting purple. All right, so 314 and 02. Okay, so let's actually erase that strange mark that I made there almost reflexively. Okay, what's our slope here? Well, I can see visually that it goes over 1 second and up. This goes from 2 to 6, so up 4. So this is 4 meters a second. All right, and that's just looking at the unit rate there in this section. But if I calculate it, I bet I'm right. Okay, he's gone from 0 to 3 seconds, and he's gone from 2 meters to 14 meters. 3 seconds at 4 meters a second should be 3 times 4, which is 12. 12 plus the initial value 2 is indeed 14. So that is correct. My quick visualization was enough to give me the correct answer there. Okay, now let's replace those points. This is 314. Okay, so he's traveling 4 meters per second, Javier is, during this section of his walk. And then he travels 4 meters here. So he goes from 14 to 18. So let's just draw our triangle on. This is 4. And then let's go here. That's 3 to 7, and that's 4. Okay. Oh, look, 4 and 4. That's actually a slope of 1. That's m is equal to 1 meter per second. So how much greater is his speed? Well, we would take his faster speed, 4 meters per second, and we want to find out the difference between that and his slower speed, which would give us 3 meters a second. Let's keep going. 14. Navenka and Juan scuba dive. Oh my god, this is a damn question from a test. Oh yes, this question from the test. So the disc represents what's going on as they swim back up and blah blah blah. Yeah, I don't create all the questions for your test. Some of them I steal. I stole this one from here. All right, which question below is true? Juan swims back up at a rate of half a meter per minute. Well, let's test and see if that's true. He starts at 9 here. This is the point 14 in the x, 9 in the y. That's 9 meters after 14 minutes. And he finishes over here at 22, 0. 22, 0. So the rise and the run here is we rise -9 and we run 8. So that's not going to give us half a meter a minute. It's not that. 9, -9 divided by 8 is not 0.5. Navenka swims back up at a rate of 4.5 meters per minute. Well, let's check that out. Here's Navenka. She's the stolid line. And here's her point up here. This is the point 10 in the x, 18 in the y. And then she finishes her swim here at 14 in the x, 0 in the y. So my rise is -18. It goes down -18 here. And then the run is 4. -18 over 4 is 4.5. Hooray! -18 over 4. So I do rise over run. 18, but it's negative, divided by 4 equals 4.5. Okay, so you just need your rise and runs. Here, you just check rise and run, and you can solve these questions. Okay, so which of the following could be the slope of the line of best fit for the data shown in the scatter plot below? Here is the point 14, 14. Okay, that's a point 14, 14. But we wouldn't say that this goes through the point 0, 0, would we? It kind of goes through 14, 14. Like 14, 14 could be a point on this line, but I would say that my line of best fit looks something like that. Wouldn't you? I think I might have drawn that a little high, but this would not be it. No, 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 no. So this will have a slope somewhat less than 1. Somewhat less than 1. Which of the following could be a slope of a line of best fit for the data shown in the scatter plot below? Okay, fine. The closest one that they have available is 1. Oh, well. They like that, I guess. How could you put a slope of 1 through there? I guess you go through here and go up to there and there and there. No, it's too high, man. 1 is too high. It should be like 0.8. But 1 is certainly the closest option that they have. So we will go with 1. Now, why are the others incorrect? Okay, we want to know our basic slopes, like 1, 2, -1, -2 by this point. A slope of 1, when it runs 1, it rises 1. So it will be there. When it runs 14, it rises 14. So that's why I said here's the point 14, 14, just to give us a spot way out there that we can look at. Okay, now that would be a slope of positive 1. We go over 1, up 1. The slope of -1 might start at 14 here, and for every 1 it goes over, it goes down 1. So the slope of -1 looks like that. Negative slopes are all going down, and positive slopes are all going up. Okay, what if it was a slope of 2? Well, then it would go over 1 and up 2, so it would go there. So it would be steeper like this. Okay, and 2 definitely is not it. 1 is the closest, but as I was saying, that to me looks like 0.8. Here comes a child. Duncan records the outside temperature at noon each day. He also records the heating cost per day. And the graph shows a scatter plot and line of best fit for his data. heating cost per day versus outside temperature. So here's the outside temperature, and here's the cost to heat his home. All right. So as we see, when it's colder, costs more to heat the home. When it's warmer, costs less to heat the home. And so how much does the heating cost per day decrease when the outside temperature increases by 5 degrees? Okay, so let's take a look here. By approximately how much? Okay, and so the approximation is given by the line of best fit. So we don't actually need to work with any of his points. His points give us data. From the data, we find the trend. The trend is represented by the line. So let's take a look, see if we can find some good points. This is not a bad point here to work with. 15 degrees, and then let's go down. That's like 1520, okay? So that's the point. Negative 15 costs $20. Negative 10 costs about, well, that looks like $18, doesn't it? Looks like about $2 or $3 costs. The cost decreases for every cost decreases by about $2 or $3 for every 5-degree increase in heat. So I would guess B here. Guess? No, I'm sure it's B. It's not 1. It's not that small. And it's not 5. It's not that big. So it's about 3. Okay. Alex has $150. Well, good for you, Alex. You have $150. She spends the same amount each week. Why do you do that, Alex? Oh, right, because you have fixed expenses. Maybe you have to take a cab every day to school because you can't make the bus. I don't know what it is. All right. After 6 weeks, she has $30 remaining. The relationship between the amount of money Alex has and the number of weeks is represented by a line. Well, the reason it's represented by a line is because she spends the same amount each week. If she spent a different amount each week, it might be a curve. It might jump around. It's not that same amount, so it makes a line. All right, what's the slope of this line? Okay, well, let's create a quick plot, all right? You just create a quick graph and then analyze it. So she starts with, that's just a terrible XY plane, Mr. Jennings. Oh my goodness. Oh, so much better. That's going to help the students so much more. 150 here is where she starts. And then this is $30 here. And that's after 6 weeks. Okay, so that would be the point, 630. And the amount of money that she has is going down like a line. So what is the slope of this line? The slope of the line will be how much money she spends each week. It will show me the rate of change of this line over time. All right, so let's figure that out. Label your points. That helps. This is 0, 150, and this is 630. Okay, what's the rise and run? Let's do another color to delight the senses. Zoom right in here. Zoom right in here. Whoa, we're really zoomed in. Okay. All right. So we run 6 months. We rise negative $120. Okay. So my rate of change or slope or M value is going to be equal to the rise over the run, which in this case, just to show you the numbers where they're coming from, negative 120 is the rise and 6 is the run. Get the signs right for these numbers. Okay. How do I know how to get the signs right? I go from 0 to 6. That's an increase of 6. I go from 150 to 30. That is a decrease of 120. Decrease will be negative. Increase will be positive. Okay, so negative 120 over 6 happens to be equal to negative 20. There it is. B. Let's check out some more questions, everyone. Who else is having fun? Jerry has a table of values representing a linear relation, but 2 of the numbers are hidden behind a ketchup spill. How did you let that happen, Jerry? How did you make this type of mistake? Well, Jerry's human, and these things happen. The values that are hidden are we don't know and we don't know. Let's figure them out. So if we go from this point to this point, we want to know what's happened. Well, let's do our these, okay? we have increased by 3. We started at -2, we went to 1. That's an increase of 3. Draw a number line and see if you're confused. We started at -6, so we went to 18. That's an increase of 24. Okay? So, and we want to know the unit rate. So we want to know how to walk it up to there and then walk it up to there. All right? And it's 8. How do I know it's 8? Rise is change in y. Okay, change in y is rise. And then over run would give us change in x. Okay, change in y over change in x is rise over run. It's the same thing as over here, right? Where? Like over here. Change in x, change in y. Okay, so you put the change in y on top and the change in x on the bottom. And here we have 24 over 3. 24 divided by 3 happens to be 8. So the missing values are 2 and 10. 2 and 10. How do I know this? I added 8 to -6 to go up here. -6 plus 8 is 2. And then I added 8 to 2 to go up here, 10. So this is 2 and this is 10. And oh, wouldn't you know it, if I go up from 10 to 18, I would just add 8, which is what I wanted. This is what I said. Okay, 19. A bus is rented for a class field trip. The transportation cost for the trip is made up of $225 for rent the bus, $50 for gas, and $2 for each bus seat. Okay. Which relation describes the total transportation cost of the trip if C is the total cost in dollars and N is the number of seats? Okay. So here, let's build it ourselves. The cost is going to be equal to $2 times the number of seats. $2 per bus seat, $2 for each bus seat. So that's the rate of change. That's the variable. It's how many seats are you going to use? You have to pay for each seat. The more seats you use, the more you pay. So cost is equal to 2 times the number of seats plus $50 for gas plus $225 to rent the bus. These are like terms, so let's collect them. C is equal to 2N plus 275. Oops, there. Not at this one, because that would be, they're giving you a discount for every person you put on the bus, and that ain't the case. Okay, let's keep going. 3 more questions and then take a little break, get some water. Okay. The student council is selling lollipops for 10 cents each. They pay 4 cents for each lollipop and spend $10 to advertise the sale. Okay, so we've got all of our stuff there. P represents the student council's profit in dollars, and N represents the number of lollipops sold. Okay, so how much profit do they make per lollipop? First, you could figure that out. Okay, so they're selling them for 10 cents, but they pay 4 cents to get them. So that would be 6 cents profit. So here, I'm going to write that this way. 0.06 times the number of lollipops they sell minus $10. This is an expression that gives their profit in dollars. I bet that's what they're going to ask me. Hold on one moment. Carrying on here. Here we go. So let's see. Which equation represents a profit? Yeah, it's this one here. Okay. Yeah. This is a positive slope, okay? The more they sell, the more profit they make. But they have this initial expense. Okay, so the equation would create a graph. It starts down here at -$10, and they would make more profit the more things they sell. Okay, so that's how that would look. Let's keep going. 2 more questions. I don't think I need a break. I think I can keep going. It was dark outside. Now I turn on the lights. It feels a little better. Okay, the charges on a monthly water bill are 86 cents per meter cubed for cubic meter of water used, plus a service charge of $4.49. Okay, so let C equal total charge in dollars and W equal the total amount of water used in meters cubed. Okay. Oh man, they just have some gross stuff in there. That's this here. Okay. Okay, so you take your flat fee and you add that, and then you add this per unit per meter cubed of water fee there. That's the relationship between cost and amount of water used. All right, let's talk through it. Okay, there's a service charge of $4.49. So that means you just pay that. Okay, so the cost is equal to you pay that service charge, and then you're going to add on 86 cents per every meter cubed. Going to multiply the number of meter cubes you use by this amount and then add the service charge. Don't say, when am I going to use this, Mr. Jennings? This is like really, I hope you're seeing this really common stuff. Okay, you see it everywhere. That's actually feeling much better. Maybe I can go to school tomorrow. We'll see. Karina has a job at a video store. The total she is paid each week is made up of an hourly rate plus $14 for transportation. 1 week she works 20 hours and is paid $215. Okay. Wait, I wasn't paying attention to anything I was reading. I was thinking about whether I can go to school tomorrow or not. Yeah. Anyway, she's paid each week is made up of an hourly rate plus $14 for transportation. Okay, so she's paid $14 a week for transportation and then her hourly rate on top of that. All right. Wow. Okay. So this is like one of their challenge problem type things. Great place to end our video. I'll work over here in the blank area. All right. So I know that she worked 20 hours and she was paid $215. So let's write this out. Her total pay is equal to some hourly rate, which I will call M, multiplied by the hours that she works, which is N. Okay. Why didn't I not use X and Y? Well, because they told me P in dollars and N in hours, plus 14. Okay. She gets $14 for transportation regardless of how much she worked. So that's our B there. Okay. Now we need to solve for M. And then we'll be able to find whether this one is the correct one or this one is the correct one. They're both close. All right. So, all right. So now we input, she's paid 215. So put that in for P. Okay. 215 is equal to some value that she is paid per hour multiplied by 20 hours in this case, plus 14. Okay. Subtract 14 from both sides. Stop me if you feel like I'm repeating myself. No, repeating oneself is teaching. Is equal to 20m. Okay, m times 20 is the same thing as 20m. Just let me do it that way. All right. Divide both sides by 20, and it really looks like number C is correct. Okay. $201 divided by 20 is $10.05 is equal to m. Want me to prove it to you? 201 divided by 20 is equal to $10.05. $10.05 is equal to M. So here's my $10.05 is equal to M multiplied by the number of hours she works plus her transportation fee gives her her total pay. C is the correct answer. And not A, which looked tantalizingly close, but it was incorrect. All right. Any questions you have about any of this stuff, hit me up by email. Otherwise, I hope your math practice is very fruitful today. Bye.